very, very interesting recent progress and opinions and comments. What this panel is about is more about the future. But we don't really have the time to really do a detailed roadmap or anything like that. It's more like I want every panelist who are just basically the speakers of today to very briefly summarize what you plan to do in the near future. Starting from me, okay? I give you, also actually I will post it to the chat window, a list of things that I'm working on recently and I'm also going to continue in the near future. The first thing is recently I finished a conceptual design document for a new version of OpenNARS. Now we call it OpenNARS 3.1, and the team now is coding it. The major change is a new architecture, which is going to split the previous input buffer into several buffers for multiple sensory motor channel, as well as an internal experience channel. And also a refined conceptual design for the control mechanism, which you all know is the current bottleneck of the system. We hope this new version will do better. Another thing I'm working on right now is another design document for compound operation, which will be related to several things. For example, it's directly related to the robotics cooperation we have with the Glamour team. Also is related to how to solve this so-called self-programming or planning functionality, and also to improve the reliability and efficiency of the control mechanism. That's one part. Another thing I'm drafting is a memo which I already shared with some of you recently about how to do axiomatic reasoning within NARS, which is not axiomatic overall, but you still need to do axiomatic reasoning. It's a local, smaller scale. For example, you need to teach it math, right? Teach it logic. What I tried is teach it, say, propositional logic, using those rules and do binary deduction and do it right. So I will continue to work on those things, as well as something already touched in recent discussion, that is natural language processing and vision, okay, which we have started, made some progress, but there are a lot of additional issues to be resolved. That will be my near future task. And also, of course, new application possibilities. That's me. For the others who want to start first.
Should I continue?
Sure.
Yes. For me, the main focus was this OpenNAS for applications recently. Clearly, it has a focus on agency and autonomy. So I personally, also for my thesis, I want to push towards robotics use cases, and I want to show that this system can make a difference in for autonomous systems which have to deal with new situations and where the knowledge or the procedural knowledge which is given beforehand might not be sufficient to deal with new circumstances. And so this is also, I was often, many years I was concentrating on procedural learning because I was always a bit convinced that such a system needs to be able to deal with multiple cores in parallel. It cannot just learn a single state action mapping like a reinforcement learner, but it should be able to change its behavior dependent on the cores which it has. So this was always a large, my main focus, so to speak. and now I want to make this succeed for robotic applications. This will entail several things like building proper sensory channels. Here I'm very open to use the best technology which is available, including ConvNets and maybe other approaches from robotics, like simultaneous localization and mapping. So I want to find ways to to utilize those technologies and to make the most of the system in terms of how much it can add for autonomous system, so that it can deal better with novel circumstances. And for OpenNAS for application, this also means for me to make it scale better. Currently, the data structure is not yet perfect for its memory. So it's a bit slow for event processing currently. And I wanted to be able to handle much richer event streams, and so it's not allowed to take too much time per event. Even though this has been improved in the last version, or last two versions actually, but there is still a lot to do to make it really scaled. This is one thing. Yes, and personally, I'm also very interested in what Robert just described with relational frame theory. I think what he found here is really a crucial component of learning, or that the stages of learning he described are essentially, I also experienced them with working with this system. So you could have something like simple conditioning between events A leads to B, B leads to C. But then you also want to be able to expose the internal structure of the events. For instance, the system can learn if this object and this object has the same color, I want to use a different behavior than when the color is different. This is a really abstract pattern. So it's the equality of the color itself becomes a stimulus to respond to. And this is the good thing about non-axiomatic logic is that it allows for such abstract patterns to be formed via variable introduction. And the only thing is it's not easy to control it properly. So it puts a lot of strain on the control mechanism to make sure that those implications with variables can properly form, and that the relevant and successful ones will remain in memory, so that the system can fulfill the relevant goals. And here it's also a key thing here is to make sure that that the useful representations survive in memory. And this is something in previous versions with the Java version so far, as Bay mentioned, we did not take too much time for the control mechanism yet. But I think this is where we really have to change some things to make sure that the right representations survive in memory. And with this new C implementation, from a control perspective, I think it's superior to the Java implementation, but not because the structure is better. It's mostly because so far it has a very simple attention mechanism, which is easy to tune, which you can easily configure in a way that it will work well across different tasks. But it does not yet capture all the aspects which the Java version captures. So it will be relevant for us to compare those control mechanisms and to see, for instance, what we miss in the C version, but on the other hand, also what do we capture in the Java version, and how can we make sure that the Java version exhibits the right dynamics as well, so that it will not get stuck in attention-wise to focus on something which is not relevant anymore. The currently the Java version has a lot of attention issues and those need to be resolved if it should work in a cumulative way like the C version currently allows. This is one thing. So control mechanism is still a large thing to work on. But at the same time, I want to push towards robotics applications, and this will include to finally work on things we also ignored, which is mostly sensor processing. How can you get a lot of, say, numeric data and make sure that you find some relevant patterns in them, which you can then reason about, so to speak. So you need some kind of sensory channel or something which can work with the scale of information. And I think what Hugo did is really relevant for us as well. Especially the visual attention is something we always wanted, but we never had much time to work on. Oh, my cat, sorry. We didn't have much time to work on visual attention yet, although we think it's a key component of an AGI. It needs to be able to focus its fovea to spatially to objects of interest. It cannot process the entire image as a whole, but has to incrementally look for interesting pieces, which in the end are also related to the goals of the system. What does the system want to achieve? And so it's, yes, this is what I want to work on.
Maybe I can add just some brief things. Yeah, thanks for that, Patrick, also what you said. My plan to work on is simply to try to make some of these experiments possible. And I, as you saw, started using OpenNARS for application and have emailed Patrick a lot about the representation of these experiments. I think I mentioned at last year's AGI conference that I would like to connect this to psychological experimental software. The goal would be to use the same software for human responders to experiments as NARS in a way to increase the validity of the results from NARS. But as Patrick mentions, it would be really interesting to have this bottom-up approach to study more and more advanced experiments. And yeah, I would simply like to continue to work on that. Thank you, everybody, for the great work you do in the NARS community.
Thank you. Maybe what I should also mention, because we have this collaboration with the Palermo team, and this is really good because.
Yes, so we are, in a sense, we are, both myself and I think Francesco, we agree with Patrick on the need to implement the NARS systems in a robot or in some kind of embodied system. Both from a practical point of view, of course, there are many I know that there are many problems in the integration of ROS with NARS and so on. But there are even theoretical point of view. For example, the good old problem of symbol grounding or whatever. We discussed a lot in the last weeks about the symbol grounding and about the role of the focus of attention. And all those things, when you implement this kind of NARS in a real robot, in a real embodied entity, in some sense, we are able to change our view because the robot give a different sense of reality. In a sense, in this way, even the theoretical aspect of symbol grounding change the aspects because there are cameras, there are moving effectors, and so on and so forth. And so I think that the implementation of NARS in a robot will be useful, both from a practical point of view, but even from a theoretical point of view. And so I greatly push toward this goal. There are other aspects which are, I think, that are interesting to considering in NARS. One aspect is a really hot topic today in neural network, in learning theories, and it is related to the big problem of bias. In a sense, a typical neural network today, there is a lot of discussion in these days on the problem of bias, of race bias, of gender bias in a typical neural network. I think that a system like NARS may be more able to cope with the problem than using a classical deep learning network or whatever, in the sense that it's more possible to understand the problem, it is more, essentially NARS is more flexible, it's more transparent, and so it's more easy to cope, in a sense, with this problem. I think it should be an interesting field of research. So the problem of bias in learning, considering NARS with respect to a typical neural network, gender bias, race bias, and whatever, may be an interesting field of research. And a related field of research, which is interesting, in my opinion, it is important in an autonomous system, is the role of ethical constraints. Today, the problem of ethics is a huge problem, which is related in some sense with the bias problem. But the problem of ethics in an autonomous system is a huge problem. And we all know the problem of Microsoft Tay, for example, the chatbot Tay or whatever. And maybe the fact that NARS, in NARS, it is possible to implement, to clearly define the ethical constraints in forms of rules, in forms of symbolic constraints and so on. Maybe another field that it could be interesting, in my opinion, to take into account. So to summarize, my interest in future version of NARS are the integration with robots and with sensor and actuators. The problem of bias and the problem of ethical constraints. In my opinion, those are three important fields of research that I would like to see in the future developments of NARS. Thank you.
Yeah, I will fully agree. We have already talked about this robotics thing, integration topic. The other two, I completely agree, and I would suggest that, in our current weekly meeting, we can find a future time to just focus on those topics that we can talk about in the context of that. Yeah.
I want to add that also important the fact that with NARS we can implement systems that are transparent and explainable. And in terms of robotics and HRI, this is very, very important, because if we can justify some action to human or in general, we can know why the agent adopt this kind of behavior. So I think that with Patrick we are trying to define a proper package for letting all the robotic platform use NARS. So we will see.
I guess
I'll jump in there. Next time it might be nice if someone just kind of selects people. It might be easier than waiting. But so as you know, I'm more about applied because I'm working at Cisco. So we're trying to do bring business value. So that's a high priority for us. So from the applied AGI side, I think that there's a couple things that could be important that we could all work that might be useful for all of us. Is we've very briefly covered the value of this meta model, the structure of knowledge, and some of the concepts that I think are very crucial to get to the next level in AGI. Last year, I was asked at the AGI conference, when do you think that we'll start to see real AGI, like human level intelligence? I said 5 years, which means we have 4 years left. So that means, so here's my strategy. I still want to do that. I'm sticking to that, but I think we could do it in 5 years. And that's going to require, I think, a lot more funding, a lot more. So on the funding side, what I'm thinking right now is what we're showing today at Cisco with what we've done together with Smart City, with you know, the open conservation, with the new stuff that we're doing with networking. I think could be quite big. IoT, retail, all these things. If you put it together, I think we're getting to the point soon that we can make a case for a lot more funding across all these different approaches that we're talking about. And I think that's why it's particularly important that, yes, I'm kind of on mic. So that's why I think it's really important that we have some kind of framework that allows us to tie all these things in together and show results today, right? So I think we can do that, and I'm not looking at a month or 2 months, but the capabilities that Oz and the team, that what we're showing right now within Cisco, I think will allow us to start to do a lot more with all of you, and that's including probably other researchers we don't know yet, but also including, you know, definitely there's a lot we can do with the open cog work and ERA. I think they're all crucial components, as well as the NARS piece. We see how all these things can fit together quite nicely. So yeah, getting that meta model in a better shape, I think, is key. Concretely, Oz, do you want to what's your wish list? We're doing so much with time series. I'm sure there's something there that you would like to mention. Or maybe he's not around. So yeah, go ahead.
Yeah, especially with the integration of time series in the model will allow us will give a system easily integrate different data modalities without you know, a lot of parameter settings, etc. So that's one of the keys.
So I think, you know, I mean, from a high level, we can get into more of our research objectives, but certainly more open NARS for applications. You know, from the open NARS side, I think that's crucial. Maybe it would be useful if we were to open source. I have to get approval, this bidirectional interface between, you know, kind of knowledge graphs or other graph systems and NARS. You know, I think that might be something that could help move the bar forward for everybody. If we can agree to some sort of a graph-based representation, along with tools to analyze the graph, tools to visualize the graphs, that could probably, you know, and then that way you can try all your various, you know, approaches to AGI and techniques, and you would have one common platform that would have the basic tools of managing the graphs, growing the graphs, distributing the graphs, cumulative learning. Different ontologies could be integrated by default into that thing. Dynamic visualizations, you know, there's just, I mean, there's a lot of fruitful things we could do by just thinking, what's something in common that all the approaches have that could benefit, that they could all benefit. I think, you know, representing knowledge in a graph we can all kind of agree to in some sense. And I know that in a sense, NARS has an internal graph representation. We just have to kind of pull that out and generalize it a bit more. But those are some initial ideas there.
Yeah, shall I go next?
Sounds good.
So just to summarize briefly what my team and I are working on and will be probably focused on for at least the next 2-3 years. Well, I've been writing a book for a couple of years, and it's coming along on the role of understanding in AGI and how the two are related. So that is on the horizon in the foreseeable future. We are using a combination. We're hedging our bets by using both NARS and ERA, and trying to learn something from that contrast and comparison. In part because I do think there are some new systems in the future that we will have to design to really move forward. And I really look forward to making some progress on that. We're already making some progress. Of course, it can always be faster. We just finished, one of my master students did a really fantastic job on creating a new tool for evaluating learners, and you'll see a presentation on that tomorrow. Leonard Eberding, called SAGE, simulation environment for autonomy and generality evaluation. And so we're currently just trying to cram as many learners in there and as many tasks as we can, move as fast as we can to produce data, because we can create more systematic comparisons of learners and results than ever before. And that will allow us, I think, to get a handle on something that is very dear to my heart, because I think we really need it, and that is some sort of a task theory, something that we can call a deeper understanding of what tasks are and how they become complex or simple by changing them for particular learners and learning styles. We are also very heavily focused on self-explaining systems. So we're beyond explainable systems, and certainly black boxes, although they do have their place still. Self-explaining systems are systems that can not only explain themselves and their actions and their plans to others, preferably humans, but also explain it to themselves and use that as a way to get better at learning. On the back burner, hopefully moving to the front burner soon, I really would like to concretize a project in cognitive perception, the interface between cognition and perception, because I think there's a lot of really interesting things to be discovered there. And I think the work that the NARS team and Cisco have been doing in combining vision and NARS is just a tiny little sliver of the top of a giant iceberg in all sorts of really, really interesting topics, and probably necessary topics to be solved for making progress towards truly useful proto AGIs or real AI. And that kind of also points in the direction of my fifth bullet here, which is applied AGI, because I really think that's a nice way to drive the work. So that's my short summary.
Can I ask a question? I mean, I think we mentioned basically not really beneficial AI, but since if we are going to have AGI working in say 4 years, we probably need to think a lot more about really like regarding goals. You know, how do you tailor these so that it is beneficial and that sort of thing? I think that there was a recent presentation with Stuart Russell, focused entirely on this beneficial AI idea, but privacy, making sure that we're not giving governments and institutions and the whole framework systems that potentially could become oppressive. You know, just we have to be very careful. You know, so there's a lot to think about there. I mean, I do like the French idea of like surveillance, right, where everybody watches everybody else, right? So there's no advantage to any one party, but all those things of safety of this technology, I'm pretty convinced it's getting quite powerful, and it will be much more powerful in a couple of years. So beneficial AI, I think, is something we really need to dive into.
Well, I think that there's a really important corollary here with, the abuse of technological advances, which of course human history is rife with examples of. And a lot of the solutions aren't actually technological solutions. They're, for instance, agreement of mutual transparency between nations and so on. And these are, while they are very important, I think it's, well, I'm not willing to, let's put it this way. I have been active in really thinking about this a lot in the last 10 years, but I'm not really willing to slow my research down to become an activist. So I think it's really important for those who actually do see this as an issue and have a conscience to figure out ways that researchers can team up with responsible activist bodies and oversight bodies and governments that we have a greater tendency to trust than to distrust, and really, you know, address this like responsible researchers. Yeah,
big problem that you see right now with the beneficial AI and privacy preserving AI and all of that is that they're typically people that can barely spell AI or AGI, right? They're just politicians or non-technical folks, you know. But like, I love what you're saying, right? You need an allegiance between the two, and unfortunately, at this point, the state of it is that most technical people that know anything about this field will probably not get involved. It's a problem.
Yeah, and there's a huge educational challenge that we have also with everyone becoming an expert in AI now.
And in my view, by the way, certainly legislation, some government body that says, okay, we're going to regulate AGI. All that does is basically makes it easier for the bad guys, you know, to have their AGIs do whatever they want. It'll be, I don't think it's like you said, it's not, it's a very complex issue, but maybe there's a way to, like you said, get the researchers together so that the first AGI's job is to, besides getting smarter, is to control the other AGI, the evolution of the other, you know, and that one is controlled by good people, like such as yourself, Chris.
Yeah, it is a complex issue, and it's a global issue, and it's certainly, in my mind, not as simple as let's just make the AIs really friendly. That's for sure.
That's a good point. I'm actually curious what others think about this as well. Like, how should this be approached, and what are possible solutions?
Well, I have to say I have tried several years to avoid this discussion. Not because I don't think it's important. It's just because I think this is a very deep problem. And most of the active voice I have heard so far, I think they get the problem technically completely wrong. And also, I don't think I can convince them just at this conceptual level discussion. So you'll see that I have tried to avoid this. Even though I think, on the other hand, I fully agree, this is crucial and we should make our point clear. Actually, we did something, you know, with Chris a couple of years ago, we write a short paper at the AGI conference to basically say that the basic argument is if you really want a beneficial AGI, the key issue is not in design, it's in education. Okay, many people still don't see it. They think they can design an AGI with a super goal, you know, just to be friendly to human beings. That's completely wrong. But I don't think I can convince those people, even though I write a paper on this previous AGI conference at Oxford, just directly talking with those group of people who is talking about super intelligence, blah, 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 blah. But it seems they don't understand what I'm talking about altogether. So I think, you know, if you spend all your time on this, it doesn't get you anywhere. So I'd better, you know, go back to the technical stuff until we really make something impressive, then people can begin to listen to it.
I think with the advent of applied AGI right now, it's another factor, right? I think, you've been doing it over 30 years. A lot of people here have been really researching AGI for a very long time, and it's not something you really have to think about too much. But if you get a company, a big company, and more companies are going to be doing this with products that have AGI elements or applied AGI elements, probably it's not something that we can avoid thinking about anymore. So it may be time, to kind of get serious, even though it's a very distasteful, complex, and there's no, you're not going to be, it's a thankless job basically to do this, but something that has to be done, I think.
I agree.
I agree with you. Essentially, but there are some small problems that are most interesting and in some sense related with beneficial AI. So for example, I mentioned before the problem of bias in learning. It is a problem, it is a technical problem, but there are social counterparts. For example, if you use a huge data set, typically the data set of faces are typically white American people and so on and so forth. So minorities are, in some sense, they may have problems. So it is not beneficial AI, but the problem of bias in a training site is a technical problem, but has some social content.
So believe it or not, I was able to get a patent at Cisco on debiasing AI, because you can actually visualize the bias quite easily by visualization techniques, and if you could visualize the bias, you could debias. I think that the issues with ML/DL are kind of insignificant, really, compared to AGI. The issues of AGI. That's when it's really kind of beneficial AGI, if you will, but or for lack of a better term. But it's when you get into these hybrid systems of machine learning, deep learning, and artificial general intelligence, symbolic AI altogether. That's really difficult. But I think the pattern recognition side, I think that's less of a problem, but it's definitely worth looking at.
Okay, who is next? Peter?
Right. Besides what we agreed, to carry out the improvements on the architecture, I think I will focus on the simplifying an attention mechanism, because currently attention of the control is one of the bottlenecks. It needs to be better understood and simplified. Later, now we have the Patrick system, NARS. So later, in the close future, near future, the metrics has to be developed. And now we can compare it to, of course, meaningless comparison between the CNARS and JNARS, but at least it will let us know in what way to tune or how to influence it. Additionally, what I would like to do is, actually with Patrick discussed, we need to find some domains to compare different AGI systems, to have them like on the board and to see how they perform. And those metrics, it also leads to my future research for the procedural learnings, for all of the goals planning, goal conflicts. It's a very, very helpful. That's for the next future, like half a year.
Okay, now we have all the panelists out, and we only have 10 minutes left. But the good news is we will be around in the next couple of days. So, and even after that, you'll see we can continue to discuss online, if not in person. I noticed Hila has raised hand for a while, so I think and who else in the audience want to say something, or you can post, or you can raise your hand.
Sorry, Pete, that was a mistake. Please ignore my.
Okay, and sorry, we didn't give much time left to the audience. It doesn't mean we don't want to, okay, because this is already the longest session in this whole conference. But yeah, if anyone wants to say something short, please.
When is the face-to-face? Is there going to be a face-to-face work session of some sort? I know we were planning to do something prior to all the the situation there.
Yeah, I would love to, but no idea what's going to happen next.
Next year?
We will see. Hopefully before the next year. we don't know. You see, this AGI 20, they still hope to have this physical conference to be held in September, but let's just see whether it can happen.
Right. Another procedural one. The presentations, are we going to have those somewhere? I mean, the actual slides, some of the slides decks were very interesting. Is there a plan to collect those and to make them available?
Yeah, why not? I assume this whole workshop has been video recorded. Also, for the speakers, I will suggest all of you to email your PPT file to Peter. Then we can probably put them all together in our website or somewhere. How about that?
Mm-hmm.
Yeah, I guess since we have been a very long meeting for the people who have been here from the very morning, we will still we will just stop as a schedule and leave the discussion for the next couple. How about that?
Sounds good. Thanks, everyone. Goodbye.
Thank you. Just a quick reminder. So tomorrow it is on underline.io, and before the conference starts, you also get an email with all the details. Okay. Well, that's then the end of the stream. Thank you all very much.
Thank you.
Thank you.
Bye.
Bye.